Good afternoon, everyone, and thank you very much for joining us today for the WGMM webinar. Our webinar is called Monitoring Methodologies in Practice, Use Cases, Pilot Projects, and Real-Life Tests. My name is Maria, and I'm part of the WGMM Secretariat. We will show the agenda for today. So this is our program for today. We will begin with a WGMM overview and then move to a series of practical use cases which have been developed by our members. And a brief housekeeping note before we start. This is a Zoom webinar, so all participants are in listen-only mode. Please use the Q&A function to submit your questions, and we will address them during the presentations when possible, or otherwise in the dedicated Q&A session at the end. This webinar will be recorded. And now, without further ado, let me hand over to Alain Mathurin, Communications Director at Fuels Europe and Chair of the WGMM Steering Group.
Thank you very much, Maria. And good afternoon, ladies and gentlemen. Thank you for joining the webinar. I'm seeing the count of the participants growing, and we are very pleased to see this strong interest in the work done by the Working Group on Monitoring Methodologies. I am the chair of the steering group and very pleased to speak on behalf of all the members. And you have here a list of members. We have, to date, 52 members in the group. And this group represents a broad value chain, cross-value chain representation. We have from the OEMs to OEM suppliers, fuel producers and suppliers, retailers, and also fleet card operators. It's probably the broadest group that we can find in Brussels, in the EU bubble, that is engaging on the entire automotive supply chain, and we're very pleased to be represented here. The story started in 2023, following the first CO2 standard approval with a recital that was agreed between the German government and Commissioner or Executive Vice President Timmermans. And in order to address this opportunity for the vehicles using exclusively RFNBOs at the time, we decided to think, how do we prove the use of the fuel? And it was also part of the request that the Commission was making to industry to come with a technical proposal to do so. We brought together those various sectors, and since September 2023, the group has been actively working. And as you can see from a few numbers that we can share, we have about 160 people that are involved in the various working groups. We had 4 subgroups in 2024, and we are now working since 25 and 26 with 2 subgroups, 1 regulatory and 1 technical, and today we will give the floor to the technical subgroup. So 160 people involved. We have, as I said, 52 members, and we have been holding more than 120 meetings to discuss, on the one hand, the technical dimension, and on the other, the regulatory aspects. And this work will be continued throughout 2026 and until the closing of the CO2 standards for light-duty vehicles. We can move to the next slide. I already shared some of the background. You see the timeline here. Maybe 2 key moments in the timeline. I think it's the report that we published in 2024, which was our primary and main objective for that year, and we produced a report that has been a very comprehensive overview of all available existing and identified technologies. The report was published in 2024. A big piece of work, 140 pages, with also a summary report that was attached to it. And this report has been, I believe, very well received in the institutional area. Firstly, because of the overview it delivers, and has been largely referenced in also some of the impact assessment documents that we have seen very recently with the automotive package. So I believe this was really an added value for all the stakeholders looking into this specific issue. We then, a year later, published our report on feedstock availability, another really critical question. Will there be enough feedstock to supply the fuels that could be required to fuel the vehicles exclusively using them? And this report comes also with a broad overview of all options. Again, here, I think I should underline the spirit of this group, and I would say more than the spirit, the rule is technology neutrality, and this we will be following. The next on the timeline and closing one is the heavy duty file, but for now we are focusing on the light duty file, and today you will see all the work that has been done around those methodologies for light duty. And diving into those, I'm very pleased to hand over to our co-chair of the technical subgroup, Mats Hultman from Neste, head of OEM partnerships, R&D products and applications. And Mats will also be moderating and coordinating the various speakers presenting the respective technologies. Mats, thank you very much, and over to you.
Yeah, and thank you, Alain, and also a warm welcome from my side. So even though I work at Neste today, I have the WGMM hat on me as co-chair of the technical group, and I'm doing this work together with Stefan Kunther. And the work of this group has been, one of the tasks of this group has been to basically see how can you prove or see that the vehicle is running on renewable fuels. And when we started the work, we looked at what are existing technologies and what good ideas are there out there and so on. And we were very positively surprised that there were so many ways on how to prove you're running on these type of fuels. And we came to up to 11 different options on how you can do this. So it really shows that this is not something that is not possible. And so it's really easy, and there's a lot of good options. And if we move forward here, you see that today we will hear of 6 of these options. So the ones that are marked in green here, those are the ones that we will see presented here today. And as you will see, they're up and running, they're being piloted, they're tested at large scale. So these are really good solutions that are out there and working. We can go to the next one then. And if we look at these 11 different, you can also sort of group them into different types. And if we start with the tracking method, it's both physical solutions where you have the physical fuel in the vehicle and you track that. But there's also virtual solutions where the vehicle guarantees that the fuel consumed is covered by a corresponding CO2 neutral fuel quantity on the market. Similar to like green electricity. So both these are covered with the different technologies here. And if we look at the actual methods, we have mechanical methods where you actually have a mechanical design that doesn't allow you to fill the wrong fuel and so on. There's also sensor solutions, both having sensors in the vehicles, but you can also have fuel markers that you blend into the fuel and measure those. And then we have electronic solutions, so digital handshakes. And many of these you will see examples of here today. And lastly, the inducement systems is important. So what happens if you don't fill the right fuel? This is also covered by the work that has been done. So for example, you can you can go into a limpo mode, for example, if you don't have the right fuel. Like that is what's happening today if you're using AdBlue and you don't fill up your AdBlue. So there are already systems available and ideas on how to do this. So that is also captured by the work here. And some of these methodologies even cover that part also directly. So there's not a separate need for a special inducement system. So both are available here. But let's go to the next one. And as mentioned, in end of December, we delivered a long report on this, around 130, 140 pages. And we also saw the need to make a summary, so more like one-pagers of each solution. So that is now also available since last year. And the group also produced other reports like the availability of feedstock. So there's a lot of interesting work here. So with the QR code, you can go to the website and find out more details here afterwards if you want to go into even more So with that, I think we can go into the first presentation on the options here. And to start with, we have Marco from Bosch and Alberto from Eurogas, who will present options 3 and 11 here. So please go ahead.
Thank you very much for the introduction, Mats. Good afternoon, everyone, also from my side. I would like to present the option 3 and option 11 together with Alberto about the digital fuel twin. And on the first page here, we see the working principle of the digital fuel twin. On the left side, we see the fuel supply chain. On the right side, the fuel user, the vehicles, and DFT, digital fuel twin, is connecting these two domains. On the left side, each material movement is digitalized, is tracked from the fuel market introduction along the distribution to the filling stations. Basically, all relevant fuel characteristics, sustainability criteria, but also fuel properties, density, etc., can be forwarded from the production to the user. On the right side, the vehicles get a refueling monitor software function into the existing hardware, typically engine control unit. And with this piece of software, they are able to precisely determine time, place, quantity of single refueling events. And when the vehicle is detecting a minimum, the refueled quantity, the vehicle requests a digital certificate regards the fuel properties in order to decide on the vehicle side, to decide if the fuel being refueled is eligible for go, no go in this context of the eligible fuels for the vehicles, but also to process the information about the fuel characteristics for better engine optimization. The goal is at the end to consume less of these good fuels, or also to create CO2 footprint certificates for the user, like a company car. These certificates provided to the vehicle are provided from the digital fuel twin platform, which again is linked to the cache systems, to the cloud backends of the fuel stations. And based on the accurate matching on the single refueling event from the data fusion from the vehicle and the fuel station, the certificates are issued and forwarded to the vehicle. At the end, this vehicle receives all the relevant information and can generate those and can track those well-to-wheel based fuel consumption, fuel data consumption. How easily and also universally this is applicable, we have demonstrated in the project Tour de Europe as a large-scale demonstration for the renewable fuels. In this initiative last year, within 4 months, 16 vehicles of different vehicle types, passenger cars we see, but also heavy-duty trucks, and also of different powertrains, diesel powertrain-based, able to burn classic, but also HVO 100 or biodiesel 100 fuels, gasoline-based powertrains for the classic gasoline, 100% renewable gasoline, or ethanol E85-based liquid fuels. On the other side, we had also bio-LNG truck from Iveco, where gaseous fuels are tracked, and that was implemented by the method 11, by the option 11, which my colleague Alberto will show in the next slide. Details about the properties, about the working principles, about the fuels, everything can be found on the tourdeeurope.eu webpage. The final report generated by the universities is also a comprehensive independent report about the tour. And to conclude, with this approach, Tour de Europe has shown that already today we have 87% mix of renewable fuels across Europe when driving more than 83,000 kilometers from Portugal to Polar Circle, from Greece to Great Britain. and using also the conventional fuels in, for example, Eastern Europe, where we don't have that coverage of the renewable fuels, we still were able to achieve overall tour footprint of minus 77%. But the 87% which are there can be immediately rolled out into the existing infrastructure across Europe. And to conclude, the benefits of the digital tracking and its robustness is basically tested with several partners. It's a tamper-proof solution because the data from the vehicle and from the fuel stations on the other side, from the cloud, different places, data is stored on different places. So it's not easy to manipulate the system on single clients of the system. It's easy to scale, and because no new additional hardware installation is needed along the entire fuel supply chain, and flexible, of course, for adaptation for any kind of new regulations. Last but not least, as a universal solution for different liquid gaseous fuels for different powertrains. These experience and, of course, the use cases for the CO2 footprint of the corporate fleets, for the logistics, for buses, are the follow-up real-life implementations, which in few slides later, my colleague Estebalis from Repsol will show in detail. But before going to that, I would like to hand over to Alberto regards the bio-LNG with convincing figures. Alberto, stage is yours.
Yeah, thank you very much. And let me share my screen to quickly focus on the bio-LNG vehicles, which was included in the Tour de Europe initiative last year. Using option 11 of the WGMM report, which is the combined mass balancing with the digital fuel twin device. And of course, this device recognized the filling events, and tracked the consumed fuel at the filling stations. But now let's focus on what is bio-LNG, which is, is the liquefied form of biomethane, renewable natural gas from biological origin, which is characterized by a very high degree of purity and higher energy density than the gaseous form, and it is stored at the cryogenic temperature. What is important is that the mean emission factor detected during the Tour de Europe was the best performing fuel, minus 52.4 grams of CO2 per megajoule, which correspond to a reduction of minus 155% compared to the fossil reference. The reason of these negative values is quite simple, because during the production process of this fuel, we avoid a relevant quantity of methane emission that could be naturally released in the atmosphere, and that's what I was saying, the reason of this best performing result. Another slide on the bio-LNG key figures. It is now used in the heavy-duty vehicles, but the interest in the maritime sector is still growing. It's a drop-in fuel, so it's compatible with all the existing engine, and is already largely available in Europe. We have, according to our detection, more than 300 filling stations already delivering bio-LNG, and with the mass balancing mechanism, all the existing 800 filling stations could deliver certified bio-LNG. Last but not least, there is a very interesting growing potential of bio-LNG fuel, As you can see on the graph, we are now, or I mean in 2023, a production of around 4 billion of cubic meters, which can reach 40 in 2030, around 100 in 2040, and 150 in 2050 in the whole Europe. So let's return to the Tour de Europe initiative. So the one Iveco S-Way LNG truck was equipped with the DFT, and it covered more than 5,000 kilometers across Italy, Austria, Germany, France, and Belgium in June last year, and it was refilled with 100% certified bio-LNG. The tour included 8 biomethane stations with 7 different energy partners. So it showed that monitoring also gaseous and liquid gaseous fuels was possible. And I mean also interfacing with different partners, as you can see on the screen. 7 was included in the tool. So that's all from my side, and now I give the floor to Eva from Liquid Gas Europe to continue the webinar. Thank you.
Thank you very much. Good afternoon, everyone. What I would like to focus today is very practical, how we can integrate renewable liquid gas into transport and in a credible and scalable way. And more specifically, how mass balance and monitoring methodologies make that possible. The question today is not whether renewable fuel exists, but how we prove their use, account for them properly, and scale them within the existing energy system. So on the screen, what you can see here is a large established energy system in Europe. We have tens of thousands of refueling stations across member states, and around 8.2 million vehicles that already run on autogas. And Europe consumes around 26 million tons of LPG annually. So this is not a niche solution. It is existing infrastructure, existing vehicles, and existing users. Which means one thing, we can decarbonize the system without rebuilding it. Let me just explain very quickly what is renewable liquid gas, because it's often misunderstood. It's chemically identical to conventional LPG, but it's produced from renewable circular feedstocks. And the 2 main examples are bio-LPG from biological waste and RDME. It's a renewable gaseous fuels that can complement or substitute LPG. The key point is for the vehicle infrastructure, nothing changes, but the carbon footprint does. And the impact is significant because more than 80% emission reduction compared to conventional LPG. So this is not a future solution. This is a drop in the decarbonization solution available today. Liquid gas is already entering European markets through existing refining processes and distribution infrastructure. Of course, the key question is scale. How much of this can we realistically produce? And according to our report, in a low support scenario in 2040, 2050, we can reach around 7.5 million tons by 2040 and around 27 million tons by 2050. This is a production that could potentially cover 100% of the LPG demand by 2050. And it's based on available European feedstocks, existing industrial production pathways, and co-production with fuels like renewable diesel. So the potential is real, but it depends on the framework we create. And because renewable liquid gas can operate within the existing distribution system, they can offer one of the fastest pathways for near-term emission solutions. That brings me to the core of the discussion, which is mass balance. In real fuel system, renewable and conventional molecules are mixed across the supply chain. So the key question is, how do we account for renewable fuels in a credible way? Mass balance provides the answer. It ensures that for every unit of renewable fuel produced, an equivalent amount is tracked and allocated to end users without requiring physical separation at every step. This is not a new concept. It's already used in biofuels, electricity markets, and other certification systems. And it's essential because without mass balance, scaling renewable fuels in real-world systems becomes extremely difficult and costly. To conclude, there are three key messages. First, renewable liquid gas allow immediate emissions reduction using existing infrastructure. Second, mass balance enables scaling within real-world fuel systems. And third, monitoring methodologies make this system credible and verifiable. So the technology is there, the infrastructure is there. What we need now is a policy framework that recognizes and enables these solutions at scale. Thank you very much.
Thank you very much, Eva, for the presentation. And next up, we have Jost Weber from Denso Automotive Germany, where he's managing the energy systems at R&D. So please go ahead, and we will hear about option 5 here.
Okay. Thank you, Mats, for the kind introduction. Today, I'm going to introduce you to the option number 5 in the report of the WGMM on the onboard fuel detection. So our technology, what we have developed, is based on current engine and vehicle technology. So in the fuel industry, on the bottom, the fuel industry is working on future fuels. We have currently 2 standards. In the case for diesel, we have the EN 590 for regular fossil fuels and blends, where you have up to 26% already possibility to blend in paraffinic diesel fuels, which can be renewable. On the other hand, there is already a standard for paraffinic diesel fuels, which can be made out of vegetable oil or in the end also from waste. And these are already today available on the market. They have a reduction potential more than 80% of CO2 reduction. For example, the HVO, which is also very popular. I come later to this point. But in the future, also these fuels have the potential to achieve 100% carbon neutrality. And these fuels, they differ a little bit in terms of properties, in terms of density, viscosity, and compressibility. And that leads also on a system when they are used to a different system response on the engine, on the vehicle. And for that purpose, our technology is now focused on a real-time onboard fuel detection, where the detection function is based on the engine, on the vehicle, and will tell the driver or the system whether it was a diesel fuel or a carbon neutral paraffinic fuel. So how does this work? We read out different signals from the engine control unit, from the vehicle side, and we have trained an artificial intelligence neural network on which the fuel detection is based on. And with this function, we can now start and detect the fuel which was used in the vehicle. To demonstrate that, we have used a model year 2015 vehicle, a series vehicle. We have installed 2 separate tanks in the back, one for HVO, one for diesel, and we can now swap between the tanks when we drive. So it's original hardware, it's an original series ECU, an original software on the ECU, so on the engine control unit, so no changes to that without additional sensors. And we read out the values from the control unit, from the ECU, via the onboard diagnostics. So we don't just plug in a connector and the detection function is running on a dedicated development hardware, and the output is connected to a screen which is in front next to the driver with a small gauge metering, and we can see whether we have used the HVO or the diesel fuel. So we can try out this under real world driving conditions. So we went on with this vehicle across the public streets. We have seen already fuels from the filling stations are available. We have more than 16,000 filling stations in Europe, up to 8,000 only with HVO 100, but also a few with plans. And for example, here you see in the center a test circuit, a test drive around our technical center. We start here, somewhere is our location, and we go on countryside roads, and then also here a little bit highway and back to the city and then back. So this is a test drive of 32 kilometers, but also we went on other roads and streets across Germany, in the cities, overland, highway drive. And we accumulated more than 1,500, around about 1,500 kilometers with our vehicle. And we could confirm that with this detection logic, it's quite accurate. We have almost 100% of correct fuel detection. And that shows and gives a proof of concept that such a technology can work solely on a system level, on a vehicle. Even we could retrofit existing vehicles, and that offers, of course, in the future potential, depending on the future regulation and what the EU Commission is demanding from the new vehicle class, which hopefully will be introduced. Yeah, that's it from my side. If you have any questions, please feel free later on to ask. And now I would like to hand over to Ellen. Yes, please.
Yeah, thank you very much. Just very interesting and impressive to see. So next up we have Alain from SP3H, who is the CEO of the company, and he will tell us more about option 6 and the work they have been doing in this area. So please go ahead.
Yeah, thank you, Mats. Good afternoon, everyone. So first, just a few words about SP3H. So we are a French deep tech company. So we are specialized in fuel molecular analysis and with a worldwide experience with fuel refining processes, fuel chemistry and data science. And since 2005, we have been developing onboard the fuel molecular sensor, able to analyze the fuel signatures in real time. And that is the basis of the option 6. So I will try to explain it with simple words because it's quite chemistry and deep molecular analysis. So let me check the notes. So just let me explain in simple words. So fuel have a kind of DNA. So it's the picture 1. So when I say DNA, of course, it's not biological DNA, but it's molecular DNA. And that DNA is linked to the fact that fuel is not simple molecules. It's like a molecular soup. So for fossil fuel, so it's very old soup, ancient forest, algae, organic matters, and maybe a few dinosaurs sometimes. And for renewable fuel and e-fuel, it's a new recipe. But every recipe lives with a fingerprint, and that fingerprint comes with the fuel molecular combinations. So it's thousands of molecules, billions and billions of chemical bonds, and all of those bonds vibrate. And this is important because near-infrared light we are using is sensitive to these molecular vibrations. So basically, we are listening to the molecular music of the fuel. So of course, some fuel are like Pink Floyd or Led Zeppelin or Metallica. Some other are more like Taylor Swift or Dua Lipa or Billie Eilish. The style is different, production are different, signature is different, and our job is to listen to it. So for the fuel itself, basically, it's first, the identity is done by the feedstock and by the process. So whatever it's fossil fuel, biofuel, synthetic fuel, e-fuel, sometimes they can look different or similar in the tank. even if they met the same standard EN 590, EN 228. But if they are not coming from the same feedstock, if they are not following the same process route, and then they will not have the same molecular fingerprint. And that is basically the heritage of the fuel. And this is what we are reading on board the vehicle. So how we are doing that? So we are using near-infrared lights. Lights are going through the fuels, interact with the molecular vibrations, and then create a spectrum. And the spectrums contain molecular information for the fuel. Then we have advanced mathematics spectrum into a fuel profile. And this profile is compared with our database with 5,000 fuels, fuel family, and blends and production routes. So basically, that takes only 6 seconds for one complete validation cycle on board the vehicles. So, and then it's turn signatures into digital compliance data. So it's like a forensic science. So what we are doing is we are adding physical evidence from the fuel itself directly on board in real time and connected and reported. So that's what we are doing right now. So how we are doing that? So first, it's not R&D, it's not nice demo, it's not a few engineers around the vehicles. So it works with real fleets, with real drivers, customers, real roads, and real operating constraints. So since 2021, we have been running everything in Europe. So more than 3,000 systems homologated on trucks and buses in operations, especially in France. And then we have already monitored more than 130 million kilometers with a certificate saving of something like 80,000 tons of certified CO2 thanks to our technology. So it means that option 6 is not a PowerPoint technology. It's a product. We are already cybersecurity compliant and certified for onboard applications. So since the last 2 years, what we have added into our system is a way to connect the system outside the vehicles. And with our partner Electromaintenance, we have developed a way to connect to clouds and to outside database and not only the ECU. So the sensor check the fuels, we are connected to the Atlas box and with a 4G antenna. And then we can store the information in the secure cloud applications. And then we can produce at any time for any routes, fuel use and CO2 certificate. So the idea is just to be sure that we know exactly what fuel was put in which vehicle for how long for each client, and then edit and produce the CO2 report for that typical use. So to try to do an explanation for what we have done, a concrete example, it's our Track and Trust HVO European Tour achieved last time in December. So we have our partners, Stellantis, Pro1, Atlas, DINEF, and Aix-Marseille Provence Métropole as a partner. So we have used normal vehicles, normal roads, so all the HVO service stations in Europe, and normal refueling operations. So we didn't change anything on the infrastructures or on the vehicle, only installed the Ashtratec kit. So we run 20,000 kilometers within 1 month, nearly 300 hours on the road, 16 different countries, network retail. So we test 20 fuel brands, 49 refueling, including also test with random diesel fuel and diesel extreme winter grades, because diesel extreme winter grade is very close to the HVO. So the benefit was savings, confirmed saving of nearly 4 tons of CO2 avoided, and then the sensor generates more than 5 million checks, over 100,000 aggregated records in the My Data and in the clouds. So that is basically information regarding the exact locations of the vehicles, HVO percentage, calculation of the CO2, distance drove by the drivers. And then in many cases, the result was exactly what we were expecting. But sometimes, and 6% of the times, the sensors have detected unexpected HVO with diesel blend. So for us, it's good results because we are not liking the problems, but it's proof that the system is useful because logistics is quite complex. You have a lot of many manual transfer with interface and human operation. It was part of my previous job, so I know exactly what it is. And then we are truly convinced that we need an onboard verification, and that onboard verification matters. So finally, what we can say is that option 6 is operational today. We are able to support compliance, geofencing, of course, inducement, and anti-tampering, what is already done. And everything can be integrated into secure architectures. And of course, that can be upgraded. So if new fuels and new molecules are coming into the field, we can train and upload that new signatures in the sensor. So it means that the system is not frozen, and that is really important for the future. So thank you for listening.
Thank you very much, Alain, and very interesting to hear. I see also there are starting to come in questions in the Q&A section here. So maybe just before we switch over to the next one, I just want to pick up on one question since we have a minute here. It says HVO has the same chemical composition as GTL, which is fossil fuel. How are the two distinguished?
Yeah, but it's like a different brand of whiskey, or so it's not exactly the same composition. Yes, it's no aromatics. It's mainly paraffin and isoparaffin, but the carbon numbers for defining the range in between low, so number of carbon between I would say 9, 10 to 16 are not distributed the same. So at the end, even if it's pure isoparaffin and paraffinic, the distribution in between paraffin and isoparaffin are not the same, and it's not the same length of the molecules. So when you are listening the music of the molecules, when you have a molecule iso with a short chain of 12 or a chain of 16, this is not at all the same pictures, and we are able to detect and differentiate the GTL from the HVO.
Thank you. Very, very interesting and impressive to hear. So thanks for that, Alain. And next up, we have Gerhard Haft, who is Business Division Powertrain Solution. We're working within Business Division Powertrain Solution and Innovation and System Engineering at Schaeffler. So, and Gerhard will talk about option 7, the bidirectional communication. So please go ahead.
So thank you very much for the introduction, Mats. I will start immediately with the overview of our system. So the basic idea when we started almost 2 years ago was, if we want to ensure that the vehicle is running exclusively with carbon neutral fuel, we will work on the refueling process. And the idea was that if we put an NFC technology at the refilling, so if we add an NFC tag on the filler nozzle and an NFC reader on the vehicle side, then we can ensure that we are using the right nozzle during refilling. NFC means near field communication. Near field communication is a subgroup of RFID. RFID is the global one, and near field means below 10 centimeter. So we quickly recognized that this method is not really tamper-proof, because you can copy such a tag and put a copy on the canister and refill with the wrong fuel. Therefore, we said we need additional measures to be tamper-proof. Our first idea was to have a bidirectional communication between the vehicle and the filling station. Also here we recognized quickly that some guys who are familiar with all the communication could create a fake filling station. And therefore we said, okay, we need a third party in this system. And therefore we we named it Authentication Authority, which is nothing else but a server in the internet or a cloud-based solution. Also with this system, we cannot avoid that the vehicle is refueled. So the vehicle needs something to protect from being refueled with the wrong fuel. Therefore, we said we need a valve between the filler neck and the tank, and we call this valve refill release valve. So we named the whole system Electric Fuel Trust Portal due to the fact that it's all about trust. So we have to trust the filling station and we need to block the fuel. Therefore, we need a portal, and that's why we named it that way. And with this system, we have a tamper-proof solution, which is providing preventing the misfueling. To explain how this authentication process works, I will show you this slide where we have the authentication authority on the top line, the vehicle on the bottom line, and the filling station and the RFID tag in the middle. When the vehicle arrives at the filling station and the filler nozzle is inserted, the vehicle can read information on the RFID tag. The most important information is how to connect to the filling station, the GPS coordinates of the filling station, and of course the fuel type and the tag UID. In general, we check all the time if the RFID tag is available during the whole refueling process. So it's not possible to replace the filler nozzle during this refueling process, which is important that you cannot cheat. With the information on the tag, we can perform already the first checks. So all checks which are running in this process are marked green. The first check is the GPS check. We can now check if the vehicle is really at the position, at the desired position at the filling station. And we, of course, check if the fuel is the right fuel. If this is the case, to show the driver that it's, or the progress of the refueling, we show the first LED going green, and we send or we connect to the filling station and send there an authentication request message. Within this authentication request message, there's also the tag UID, and the filling station can prove if the tag that was read out by the car was really the tag that is from the filling station. With the request message is forwarded to the AA, to the authentication authority, and the authentication authority can now check if the filling station is a certified filling station. It can even check if the fuel in the fuel tank of the filling station is a certified fuel or which kind of fuel it is. And if it's okay, it will sign the message and send it back to the vehicle. The vehicle can now check the signature. All these checks are done digital. So checking a digital signature means having a public and private key. It's the typical way to check the digital information. After checking that, and if we have created now the trust in the filling station, we illuminate the second LED and we open the refill release valve. After refill release valve is open, the vehicle is ready for refilling, and we communicate that to the filling station. The filling station can then turn on the fuel pump, and you're ready to refill the car in that case. After refilling, the nozzle is put back into, or is taken out, and immediately the refill release valve will close. And if the nozzle is put back into the dispenser, then the filling station can create a digital receipt. And within this digital receipt, which is sent then to the vehicle, you can perform the final checks. You can again prove, was it really the right fuel? And you can check if the fuel tank level increased in the same way as the amount of fuel was delivered. You can also hand over with this digital receipt parameter of the fuel, so you can adjust your engine control unit according to the fuel that was sent. We have put this system into 2 demo cars together with our partners, HNG Europe and Toyota Europe. They both sponsored us 2 demo vehicles, and we have put the system into these 2 cars. We worked together with Elaflex. They supported us in integrating the RFID tag into the filler nozzle, and they supported us by doing refueling tests with open and closed refill release valve. And finally, we have the Kempe GmbH, which are operating filling stations close to Nuremberg. And they supported us by doing some video recording on their filling stations. Thank you to these partners. Thank you very much. I will now show you a video of a refueling process at the filling station. You see on the left-hand side the video and on the right-hand side the process that I explained right before. These two, the video and the diagram, are synchronized so that you can see how fast each step or how much time each step takes. And I will start the video right now. Please see also the LEDs which are in the window above the filler nozzle, filler neck. They are going green. It's within the reflection of the filler of the dispenser. You see, the whole process does not really take much time, and it will not interfere the refueling process much. And this is exactly the point what we wanted to demonstrate. Such kind of methods do not really it's not taking more time than reading a credit card, for example. So at the end, we think we have a proof of concept for this option, and we think this is a tamper-proof solution which has the big advantage that it's preventing a misfueling. Thank you very much.
Thank you, Gerard. Very interesting and very clearly presented. I think we have time for one question here before we move on to the next speaker. There's a question here in the chat. RFID solution. In case of misfueling attempt, all nozzles in the infrastructure needs this NFC technology. And what happens if a vehicle without NFC tags arrives to refuel? Is it possible to refuel?
Yes. So we were thinking about this. The point is that if you're coming with an old car to the filling station, we need something to do. So either there must be some kind of button to press that you overcome the system so that you release it, or the filling station anyhow does not care and activates the fuel pump anyhow. So this in my example, I explained that the filling station is waiting for a response, but it's not absolutely necessary to wait for it.
Okay, thank you. So with that, I think we can head over to the next speakers. We have a look towards the future, heavy-duty vehicles in the spotlight. So although we have been focusing on passenger cars and vans, many of the solution works also, of course, for heavy-duty side. And here's an example of that. So we will hear Estebales and Hector from Repsol and Christina from Prio presenting this. So please go ahead.
Hello.
And sorry, maybe I mentioned Hector is from CC, so sorry for that. It's just a correction.
Hello, good afternoon. Are you already seeing my screen? Because I cannot see it here shared.
Yes, we see, but please go to full screen presentation mode.
Okay. Are you seeing now?
Yes, perfect.
Okay, thank you so much. Let me just, oh, sorry. So my name is Christina and I'm from Prio. I'm here. Thank you for being here. I'm here to share our experience with the biofuels in HDVs. Firstly, I would like just to show you that based in our experience as biofuel producers, we have developed a range of solutions, both for heavy duty and light duty vehicles that you can see here, ranging from a B15 blend, so a more general solution that we have available in more than 200 gas stations, passing through intermediate solutions with 20 to 50% of biodiesel, and then ending in what we believe are the most promising solutions with 2 carbon neutral fuels, our zero diesel B100, which is biodiesel, and zero diesel HVO. They are considered carbon neutral fuels, and they are currently in use by several HDV fleets. And that's precisely what the case study that I'd like to share with you today is the usage of zero diesel B100s in two Scania trucks from Transportes Aguieira, which is a customer and also a transport company that works with us. They have been using B100s since February 2024, so more than 2 years now, more than 100 cubic meters, more than 400,000 kilometers usage. They have been refueled when 100% certified biodiesel. They have been supplying it in 1 service stations. So far, all transactions are being monitored and registered to our fleet card system with mileage control. These two vehicles have also participated in Tour d'Europe. I would also like to share that as we are certified by ISCC, and we have developed this certificate of emission reductions to our customers, as there was a need for that, so that they can comply and report their emission reductions by using these carbon neutral fuel solutions. And thank you for your attention. I'll pass to a colleague from Repsol.
Thank you. Good afternoon, everyone. Thank you for joining us. It's a real pleasure. Before talking about real cases with digital fuel twin that we had in Spain with CC and with ALSA, let me remember just one thing. We need all types of technologies and energies if we want to achieve to be zero and net zero in 2050. And that's why Repsol takes a technology neutral approach in order to have this same aim to be neutral in 2050. And in that case, we need real immediate solutions, such as renewable fuels, such as these eligible fuels we are talking now in this speech. And this is the sample of diesel Nexa. Diesel Nexa is the name in Spain for renewable diesel, and it is also our highest quality diesel in the market. And we have scaled it really quickly. We started in 2023 with more or less 50 gas stations with diesel Nexa, and now we have more than 1,600 gas station with this fuel, with this alternative fuel. It's 100% origin, renewable origin. It is compatible with all the vehicles, and that's why we need immediate and real solution for these all types of vehicles and that are running now. And it's compatible with all the infrastructures. We all know that. And in that committed, Repsol is really committed not only in putting this alternative in the market, but also in converting its industrial site. We have committed more than 2 billion euros investment trying to convert today industrial sites to multi-energy hubs to produce different renewable fuels. And in that sense, having... Sorry. And in that sense, we have scaled the solution really quickly. We have it in the market right now. So as you said, we need different types of monitoring technologies in order to verify that vehicle by vehicle, they are running only exclusively with renewable fuels. And we need simple solutions, simple and really simple putting into the market. And Marco said, the technology, digital technology is really easy to use, it's really easy to implement and to scale up. And we have 10 tested it in the market from June to December of last year with two of the main clients we have today. One is CC, that is a company dedicated in one of its brands to freight transport, and also with ALSA, passenger transport. We can check and we can verify from the origin of the fuel to all the value chains till the gas stations until the vehicles that we are using renewable fuel, that we can certify the use of renewable fuel, and we can certify and quantify the CO2 emissions. And in case we do not use renewable fuels and they fueled with fossil fuels, this technology could also check that there was not renewable fuels, and this is not counting in the CO2 reductions. So thank you, everyone. And now we are talking with TC, that is going to talk about their experience.
Good afternoon. I'm Héctor Cebrián, Head of Institutional Relations and Sustainability in CC. And CC is a supply chain management company with many divisions as logistics, transport, and industrial services. And related with the sustainability, the main impact is the emissions of our truck fleet. And because of that, we have many actions focused to try to reduce the CO2 emissions. No? The main action that we have been developing in the last years is the use of HVO in our trucks. We start with the first operations in 2022 together with Repsol, and it starts only with 10 trucks, and today it's more than 300 trucks, 30% of our own fleet, and is approximately 8,300,000 liters. The main requirements that we have to try to advance with the decarbonization with this action, with the use of HVO, is to prove that is sustainable. We were able to demonstrate that we could reduce more than up to 90% of the CO2 emission. We need also to maintain the operational flexibility that demands our logistics and the logistics of our customers, and also for sure we need to balance the competitivity with sustainability. In that case, HVO only focus on the extra cost of the fuel is a very efficient solution, and we believe that is going to be for the next years like the main option to decarbonize. Nevertheless, it's quite important to try to advance with the traceability of the use. No, that is a fuel that could be used in the same vehicle, and because of that, we need to prove that we are not using fossil fuel. No, and in this moment, our 8 million liters that we consumed last year is using the mass balance system that we have this commitment with many of our customers, and we use some of our tracks of our fleet to try to achieve that target, and after that, with a third party, we demonstrate that there is not a double counting. Nevertheless, it's important to advance with the system, with BOSS and with Repsol to try to make this digital traceability of the use of HVO. And we start in June of 2025 until January 2026 a pilot project to try to demonstrate that it's possible to certificate in a digital way with 3 of our trucks. And we were using at the same time HVO and diesel. We consume 130,000 liters in that period, and it was in 2 different stations, in the private stations of Repsol and public stations. No? With all the information that we have, we were able to show some certificates, and you could see that is like a reduction approximately of 70%, because in that case, not always it was refueling with HVO. It was also in some cases diesel, but we could prove that we could split on difference when it's using HVO, when it's using diesel, and this is very important to us. To summarize, I think it's an important technology that is going to allow us not only to make more trace of the use of HVO, it's also is going to be a solution to try to prove to the tools, to prove to the institutions that when we are using a combustion vehicle, it's possible to use sustainable fuel. No? And we expect that it's going to advance in the future. Many thanks for your time.
Thank you very much. And very interesting to hear here. And I really hope that everyone that has been listening now has got a good feeling that there are many good ways on how to do this, and it's already working today. So very thanks for all the good presentations. And now we will head into the Q&A section. So I'll just kick off the questions here, and I think we can start with Alberto. There's two questions for you here. So first one is bio-LNG compatible with all existing engines, including diesel and gasoline engines?
Yeah, thank you for this question that gives me the opportunity to clarify this point. Bio-LNG is compatible with existing LNG vehicles, not gasoline or diesel vehicles, meaning that no adaptation, no technical modification of the existing vehicles are needed to run also on the biological version of LNG.
Thanks. And the second one here was for the Iveco experience. Is it possible to configure the system to force the truck to take exclusively bio-LNG and be blocked if it's refueled with regular LNG?
Yeah, of course it is possible. In this case, this means to adopt option 3 instead of option 11. Option 11 is based on the virtual tracking, while option 3 on the physical tracking, and of course it is fully possible. So both possibilities can be also applied to the bio-LNG vehicles.
Perfect. Thanks for clarifying that. That's one of the key points for today. So then there was a question for Joost. For option 5, did you measure the blends with C14?
So we tried out also in the past some blends between diesel and paraffinic HVO, and the blends we could detect, but C14, I don't know what C14 refers to the C atom chain, so I cannot tell what the chain length was in the HVO because we used it from the supplier, and we did not go on a spectroscopic analysis like with the DNA, with the sensor, where you have the clear chemical composition. But of course, depending on the processing, the chains are a little bit different and the chemical position is different. I think we can distinguish the blends we tried out in the past. But at the moment, we did not put more effort into this. But yes, it's feasible, yes.
Okay, thanks. Then there was a question on, let's see, could you highlight what kind of development is required to make HVO 100 CO2 neutral fuel in the future? And maybe I could clarify a bit on that. So all these fuels that we are discussing here, they're made from renewable components. And when you burn those fuel, you just circulate the CO2 in the atmosphere instead of adding CO2 in the atmosphere. As when you have a fossil fuel, you add CO2, but these ones are just circulating CO2. So actually from a tank to wheel perspective, they are CO2 neutral. So that is how it's explained here. And it's then if you look at it from from a complete perspective with the production and so on, then it differs a little bit with them. But it's also the same for electrification or other solutions. Also, when you take in the complete chain, you have some smaller emissions during the production and so on. But the big thing with these type of fuels are that they're circulating the CO2. So let's see what more we had here. There was one for Alain on option 6. Is it also possible to integrate this into existing vehicle fleets? And if yes, how complex will that be?
So the question, the answer is yes, because we already did it. So as the sensor is the size of the hands, it's very easy to find a place, whatever it's buses, truck, or light-duty vehicle, as we did, because it was on used vehicles. And so it takes 2 hours maximum to connect the sensor. And then after just having the connections to the clouds to get the report and starting to compile the data. So it's quite easy, 2 hours maximum. So very not a long time to stop the vehicle in order to make the change.
Thank you. Then there was a second part here. Will the molecular sensor be able to pick up fuel markers within the fuel DNA?
The answer is no. If the marker is a very small quantity, like tracer, because it's a ppb or ppm, as the diag is done on the molecular structure of the fuel itself, the tracing agent will be not analyzed and will not affect also the quality of our signals. So no possibility to detect the tracing agent with near-infrared.
Okay, thanks. And maybe just to highlight on that, I mean, you're looking at other parts of the fuel to detect it, and there is actually option 2 in the report, which talks about having this type of tracers that you blend into the fuel and then how you measure that. So that is one of the solutions mentioned in the report, but that is something different from what we have seen here today. Also, maybe to clarify, sometimes we talk about here CO₂-neutral fuels, but there's also a wording called VEF, vehicles running exclusively on eligible fuels. And these are basically targeting, it's the same thing, it's just that the wording has changed now in the proposed legal text and so on. But sorry if that is confusing, but it's basically talking about the same thing that's there. So. What else do we have here? Really good to see these questions. They're really good. For Christina, for the heavy-duty side, how do the feedstock differ from B100 and HVO100 within the supply chain?
Thank you for the question. Actually, the feedstocks for B100 and pure HVO can actually be the same or very similar, like used cooking oils, oleins, food waste. The key point is that they must be fully traceable throughout the supply chain, and this applies for both of them. The main difference lies then in the final pre-treatment stage before the processing, as HVO requires a more advanced refining step than biodiesel.
Thanks. Then I'm checking what else we have here. Then we had one more to Alberto. Can option 11 for bio-LNG be used also with bio-CNG injected into the natural gas grid?
Yes, thank you for this additional question. Of course, it is possible. And let me say that option 11 is the ideal methodology for the natural gas grid, because we can apply an equivalent principle, as we mentioned before, like electricity. So we can combine into the same grid renewable methane and natural gas, and ensuring that the needed quantity for VEF or carbon neutral fuel vehicle are available into the grid.
Thanks. And then there was a second question for you here also. Which methods are available for bio-LNG? Are you able to detect bio-LNG on site?
Yes, yeah, not all the methodologies are suitable for gaseous or liquid gaseous fuels, but as we mentioned, option 3, for example, and option 11 are good. Not only one, these are not only one methodologies that are good, but if we require the physical detection, we can actually detect the bio-LNG on site.
Thanks. Then going into another area, I saw there was a really interesting one in the Q&A here that is a bit different than the others. That it asks about how can refueling via a jerry can be integrated into these systems. So if anyone in the group would like to comment,
Yes,
maybe
please.
Alan could give a comment on if you fill up with a separate can, would that affect your solution?
I would like to answer this question.
Oh, yeah, please do also.
So in general, I think this was a question during my session, and the answer is quite simple. If you use your system to enter a kind of emergency refueling, and we store that in the system, and then we send it to the filling station, and if you refill next time at the filling station, it is stored and it is reset. So this is one option. Of course, there are other options. The main thing is there must be a possibility to do an emergency refueling via can.
Thanks, yeah. Very good.
Yes. And for our system, Mats, yes, we did some refueling with a can. So for us, as we are measuring at the end molecular content, whatever it's come from a can or for a jerry can or for a petrol station, it's exactly the same. So today our system is very close to the engine or just after the engine, because it's mandatory for the French homologation. But we are developing right now with some partner system which will be able to detect at the filling place, so directly very close to the tank. So for us, whatever it's from a jerry can or from a petrol station, it doesn't change anything.
Thanks.
Mats, if I may jump in. Hi, my name is Tobias. I'm chair of the political working group, and I just wanted to mention that for the inducement system, so what happens if you are using the wrong fuels, we are in favor of as much flexibility as possible for the customer. And that would also mean that the car is not stopping immediately, but that you at least can fill in some fuel from a jerry can, or at least go a few kilometers or have a few liters as a buffer for your system. I think an inducement can be comparable to the AdBlue system, where we also have a multi-stage escalation system that warns you several times, and only in the end, only if you're ignoring all the warnings, then the vehicle will stop.
Just to add a comment, Tobias, it's exactly what happened in France since 2020, where you can use B100 exclusively. So they have put in place, the French authorities has put in place an inducement system, copy and paste from the AdBlue system. So you have a warning in the driver dashboard then you can run and drive for a few hours and then start degrading modes. So yes, it's definitively something which can be implemented in more larger, I would say, occasion. But it's already worked like that in France since 5 years.
Thanks. And thanks, Tobias, for also stepping in. I was just about to invite you here to ask about, for more a political context, where does the WGMM stand politically and how does the Commission see our work? And maybe just to introduce you also, it says share of technical subgroup, but you're actually a share of subgroup 1 here. So please explain that also.
Yes, thanks a lot, Mats. We are in quite interesting political times right now. As Alan has said in his introduction, that this recital that there should be a vehicle category for vehicles that are exclusively supplied with eligible fuels. It's already mentioned in the last revision of the CO2 emission standards. Actually, it was a compromise because the German Transport Minister Volker Wissing has built a blocking majority. That's something you can do if you have 40% of the EU population behind you. The Commission promised him to find a solution here, and then Germany stopped the blocking position. Nevertheless, such a vehicle category was never proposed. And we were quite disappointed when we saw in the proposal of the revision of the CO2 emission standards in December last year that the Commission has not proposed to introduce such a vehicle category. We even were more surprised because in the impact assessment, in the scientific impact assessment of the Commission, such a vehicle category was mentioned in the preferred scenarios. For that reason, we now hope that the European Parliament and the Council will introduce such a vehicle category in the legislative process. It was already mentioned by the EPP, the largest political group in the parliament, that they are in support of such a vehicle category. And in addition, we also have a German position on the automotive package, which includes that the Commission shall work on such a category immediately. We, of course, as WGMM, have discussed it with the Commission many times. I think in principle they are in favor. They see some advantages and disadvantages for different methodologies. We would definitely urge the Commission to allow as many monitoring methodologies as possible, and also in future to stay open to new innovations and new technologies which may arrive. And we are quite confident that in the legislative work, we will be able to bring back a vehicle category for the exclusive use of eligible fuels. Thanks a lot.
Thanks, Tobias, for clarifying this. So I think we're coming to an end here, and we have covered almost all questions. Thanks a lot for all the participants here for the good questions and for the presenters for good presentations and for answering all these. So for final words, I would like to hand back to Alain to close this up.
Thank you very much, Mats. And I would like to start by thanking all our speakers today for having taken the time to tell us many more details about those multiple technologies that we had identified in a report, and that now you have been able to see almost in real life, building on the various examples that were shown about how these were already tested, if not in use. So what makes me just think when I hear with all I heard today is 3 elements. Firstly, technology neutrality as its best. We have 11 various options, and out of those 11 options, individually, we have at least 5 or 6 options that are today real innovative solutions when it comes to the means to prove the use of the fuel. Innovation indeed, you can see the dynamism of our European industries, showing once again that industry in EU has a strong innovation capacity and can be front-running. And I believe that we are very pleased to have in our membership today all those very forward-looking companies. The other element, I think, also important to remember is it's not just a nice story. It is there. On the one hand, we have the fuels. You have seen in the presentation from Gera that we have already a map pretty well populated with about 7,000 100% HVO fueling stations. We have a number of others with various degrees of blending, but you also have the gaseous 100% fueling stations. You have also E85, which is an additional one, not exactly in the way we have it, but still the options are there, and Europe is starting to be covered. There is work to do, but we are 10 years before the deadline. The deadline is 2035 when we have to apply the 2035 target that the Commission is currently putting for review. And I think that vehicle category, and I would like us all to remember this terminology, so I will repeat it, a VEEF, a vehicle exclusively using eligible fuels. So basically here again, technology neutrality on the fuels, as long as they meet the sustainability criteria that are required under the RED. Well, such vehicle, within 10 years, we have a tremendous opportunity. The quicker and the faster we can bring them on the market, the quicker and the faster we can test it, and we can make sure that at the due time, 2035, we have vehicles that run, we have the fuels available, and we have also the technologies to prove their use, all tested and all absolutely, I would say, safe. This is a strong message that I would like to bring to the policymakers. The WGMM has delivered a lot of technical and political work. I believe we can be a real trusted partner to identify the best way to implement this option, which, as I already heard during the presentation, is the one that will help us to achieve our objectives because it is complementary to electrification. We're not here into a battle or any kind of competition. We need to get all the solutions there. And I think we are showing you how serious the entire value chain is in trying to achieve those objectives. And I believe and I trust that the policymaker will take this in consideration. With this, thank you again to our speakers. Thank you again to the Secretariat of the WGMM. Thank you to the chairs of the group for all the work they have done. And two elements, I had a question from Per on the feedstock availability report. We have a summary report on our website, and the full report is currently work in progress and will soon be published. But all those reports can be found on our website, wgmm.eu. With this, I thank you very much, and we hope to see you soon at another next webinar. Thank you.